In this video, we're going to look at the operations with functions. Now, we've worked with operations with polynomials and in the past, so we can now call these polynomials more specifically polynomial functions. And we have four very basic operations. We have addition, subtraction, multiplication, and division. And we'll say we have two functions. We have an f function, we have a g function. We can now operate with these two functions. So what we have in parentheses here, we have an f plus g. This is equivalent to taking f of x plus g of x, and the way we pronounce this is f plus g of x. We can also take those same two functions and we could subtract between them, or in other words called f minus g of x, and this is just f of x minus g of x. We have multiplication, so we can do f times g of x, which is taking both of our functions and multiplying them together. This could lead us into just distributive property. We could FOIL, we could take a binomial times a trinomial. It really just depends on the functions that you are given. And the fourth and final operation is division, and this is pronounced f divided, or f divide g of x, which is f of x over g of x. And there's a special condition down here, which we'll get into later, which tells us that our function on the bottom of the fraction cannot be equal to 0. And if you know anything about dividing fractions, we're not able to divide by 0. So in this case, our function cannot be equal to 0 as well. All right, so let's look at some examples. Here's two functions that we have. We have f of x is equal to x squared minus 4, and we have g of x is equal to 2x plus 1. Let's find what f plus g of x is. Well, I've got them labeled in colors, so really what we're trying to do is we're trying to take the yellow function and we're going to add to it the like terms from the pink function. So we're taking yellow plus pink, and if you notice, the only like terms that we have here are the negative 4 and the positive 1. Because the x squared and the 2x would not be considered like, so when we do the negative 4 plus the 1, we can make that a negative 3. So the function f plus g of x is x squared plus 2x minus 3. And there's your answer for that one. Let's try f minus g. So the same idea, if you look back up at our f plus g, all I'm going to do is change the plus sign to a minus sign. So we got our yellow function. We want to subtract away from it our pink function. Well, we need to, 1, drop down the x squared minus the 4, and then we're going to distribute the negative sign. So that gives us negative 2x minus 1, and then we look for like terms. Well, x squared and the negative 2x are not like with anything, so we leave that in our answer. We do have like terms with the negative 4 and the negative 1, and when we combine those up, we get minus 5. So the answer to f minus g of x is x squared minus 2x minus 5. That's adding and subtracting. Let's try multiplication, and we're going to do that with two different functions. So now we have f of x is going to be x squared plus 7x plus 12. G of x is going to be the function 3x minus 4, and we want to know what f times g is. Or in other words, what is yellow times pink? Here's our yellow function times the pink function. And what you see here is that we're going to have to do 6 different distributive properties to be able to combine like terms. When we distribute the 3x through the x squared plus 7x plus 12, you're going to end up with this product here. 3x cubed plus 21x squared plus 36. And then we're going to go right back through that again with the negative 4 with 3 more distributive properties and write down those products, which happens to be negative 4x squared plus the 28x minus the 48. Now this is really strung out. We need to make sure that we combine all of our like terms. Now if we go through and we look, we see that we have some like terms here with 21x squared and the negative 4x squared, but we also have like terms with 36x and negative 28. When you combine those up, we end up getting 3x squared with 17x squared, 3x cubed plus 17x squared, and the 36x minus the 28x gives us 8x, and then finally the negative 48. So our function f times g of x is the following polynomial. The last operation, f divided by g of x. Notice that yellow is on top, pink is on bottom, so we write the yellow function on top of our fraction and the pink function on the bottom of our fraction. So there's our yellow function. We need to make sure that is over the pink function, 3x minus 4. Now remember earlier I said that we have restrictions on this, that the g of x function, the one on the bottom, cannot be equal to 0. And here's why. Anytime we have variables on the denominator, no matter how early or late in the problem, we must check for that restriction. And because we are not able to divide by 0, there is always a number that you could plug in for x that would make that denominator equal to 0. So how we work around this is that we're going to solve the equation equal to 0 so we know that we can omit that number from our domain. So I find my restriction, I take what's on the bottom, 3x minus 4, make it not equal to 0, and just solve it like an equation. So add 4 over, divide both sides by 3, therefore x cannot be equal to 4/3. What this is saying is if you were to go up to somebody and tell them, what are all the numbers that you're allowed to plug into this f divided by g of x function? Well, you're allowed to plug in any and every number you want, just skip over 4/3. That's what that means. Okay, so we're going to look at just 2 more different functions and go through all those operations once again. This time our function f of x is going to be x squared minus 5. The other function g of x is going to be negative x plus 8. And we'll go through all those operations once again. F plus g, f minus g, f times g, and f divided by g. So starting with f plus g. Let's take green and let's add to it the like terms of blue. Well, here's my green function plus the blue function. Notice that our like terms, again, are only the negative 5 and the plus 8, so x squared minus x will be included in our answer. And then negative 5 plus 8 will give us positive 3. So there's your answer for f plus g. Moving along to f minus g. Similar to the addition, change the plus sign to a minus sign. So we got green. Let's take away the like terms from blue. Go to our answer, the x squared and the minus 5. We distribute the negative sign. We get positive 8, or positive x, and then minus 8. And our like terms, once again, are the negative 5 and the negative 8, which would give us x squared plus x minus 13. Okay, the third operation, f times g. Let's take green times blue. There's my green function times the blue, and more foiling here. So we go first, x squared times negative x, we get negative x cubed. We go outside, x squared times 8, we get plus 8x squared. Then we go inside, negative 5 times negative x, that will give us a positive 5x. And then for the last term, negative 5 times 8, we get negative 40. If you scan through the problems, you'll see we have no like terms, so that polynomial right there will be our answer for f times g. And the last operation, f divided by g, green on top, blue on bottom. So there's the green function all over the blue function. And whatever is on the bottom of the fraction, we have to check for a restriction. So the bottom here is negative x plus 8. Well, in this case, instead of subtracting the 8 over and having us divide by negative 1, we could do this all in one step by adding the x over. So 8 can't be equal to x, or in other words, x cannot be equal to 8. We are allowed to plug in any number we want except for the number